In this particular question, we have an equation for a pendulum. And so this equation, let me zoom in a little bit, will be D is equal to 3 sine pi on 2 of t. Okay, and what we're asked is how far up and down does the pendulum bob move from its lowest to highest point? So we've got a pendulum here, and it swings back and forth. So we're trying to ask what's this distance from here to here. All right, so hopefully you understand the equations of sine and cosine that you're going to be using. And I'm just going to plot this guy for you, but it is a calculator assumed question. It is 1 mark. It's very easy. You basically just times 2 by the amplitude, which is the guy at the front here. So you can say it is equal to 2 times by 3, and that's equal to 6. Now, the units of this question is in millimeters. So there's 1 mark straight away, but let's plot it so you can see what's going on. So we go to graph and table. I'll clear all my other work. Now, because it's pi, right, you need to make it real sure that you're in radians. So I'm in radians now, it's all safe. So 3 sine, and then I'll bring up my keyboard to get pi, wherever it may be hiding. There we go. Pi divided by 2 times by x. Okay, and then I will plot this one. Okay, so we can see that the pendulum goes up to 3 and then down to 3. So that's why I need to times that value by 3 to get 6. So there's a distance of 6 millimeters there. Cool. That's the first part done. And so the next part is B. All right. How long does a complete swing of the pendulum take? So that's the question. How long is the period? The period. So let's go back to the basics of these sine questions. So y is equal to a sine bx plus c plus d. Okay, so what we can say here is that a is our amplitude, b can tell us our frequency or period. So it's our frequency, right? So there's this special equation where you can say t, which is the period, how long does it take? So if we have a sine wave like this, we're asking how long does it take to complete one? How many seconds, right? Whereas the frequency is how much of it is done in a particular second, right? So that's 1 second, and that might take like 3 seconds, for instance. So we're trying to figure out this one here, the period. So the equation you need to know is that t is equal to 2 pi over b, all right? Or it's equal to 1 over frequency. So that's cool. We've got this value of b here, right? That value of b is pi on 2. So this is going to get a bit confusing. It looks a bit weird, right? It's like 2 pi all divided by pi on 2. Oh, there's like double fractions going on there. Remember, you can make this a lot easier by saying divide by pi on 2 and then flipping it later. Or you've got a calculator. You can make this super easy. Okay, so let's go back to main. And then let's say it is 2 times by pi divided by 2. And you can just hit enter. Now just make sure that you're in standard, because if I hit this, well, it actually ends up being a nice number, but sometimes it doesn't show pi. Like for instance, if I have pi here, it'll give me a nice big long number here. But if you put it into standard, you don't get that occurring. So it's equal to 4. So what we're saying is that our period here is equal to 4. Okay, and so that is for seconds from the question here. It says it's in seconds. There you go. That's the answer to part B. Now, the next part, part C, asks us if the pendulum starts to swing twice as fast. All right, so 2 times as fast. Write down the equation that models this. Okay, so if you have a higher frequency, all right, you move faster. So that value of b, if it goes up by 2, then it will be moving faster. But let me prove it to you. Let me go back to the graph and table, and I can plot this one here, right? And I get that one. Let's say if I grab the same values and I just times it by 2. What happens here? Well, it's going to be twice as fast, so it's going to get squished in the x direction. See, it completes twice as many in there. So if you're wanting the frequency to go twice as fast, you have to double that value of b. So we originally started off with t is equal to 3 sine of pi on 2 times by t. All right, twice as fast. All right, would be equal to, keep it the same amplitude. That doesn't change the x direction. If I change that and I decide to make it 6 here, and I don't times that guy by 2, then I just get it twice as big, not twice as fast. So then that would just be that 2 divided by 2 times by pi. You can put it into your main if you want, but simplify it to just being pi t. And there you go. That is your answer. So hopefully that all makes sense. There are so many questions like this on my website. So click the link below. You get the original question as well in the link below. And leave some comments. Tell me what can be improved. I'll be happy to help if you have any questions.